Okay, when it asks you to use the identities to find the value of each expression, you can really use any identity to do that. They've given you cosecant. That should make you immediately realize that you have sine if you flip that. If you are given sine, then of course you can either use your SOHCAHTOA, which is your opposite over hypotenuse, to solve for your adjacent side, or you can use your identity of sine squared plus cosine squared equals 1. Either way, if you're trying to find cotangent and cosecant, you do need to have that cosine. And when you solve for it, you would get that the cosine is 4/5. So that is going to help you find the other two. If you know the cosine, your secant is just the reciprocal. So to find your secant, you're just going to flip your cosine. To find your cotangent is going to be your cosine, which you already found, over your sine. And so you can also solve for that. Pay attention to your positives and negatives. They're telling you cosine is positive. They told you sine was positive. This means your cotangent will stay positive as well. For the ones that say simplify, you will not be given the right side. You will just need to simplify it. And typically your instructions will say that you don't want any fractions in your answer. So given something like this, you want to look at the easiest way to convert this to a more simple function. So I would start with, of course, rewriting in sine and cosine to see if that helps. In this case, it does. These will cancel. You will get negative sine of x. That's as simple as you can get it. If you were to end up with something that has a fraction, obviously you want to get rid of the fraction using some of your reciprocal identities. But once you've gotten it down to a simple trig function, then you are finished with these. For verifying, you are going to be given both sides of these. And so you can choose whichever side you want to, or you can simplify both of them to see if they come out to the same thing. If I'm looking at this, though, I have tangent, cosecant, and secant over here, and I'm trying to simplify it to something with just cosine and sine. So I would probably rewrite all of these. I would rewrite my tangent as sine over cosine. I would rewrite my cosecant as 1 over my sine, as my secant squared as 1 over my cosine squared. And then I'm going to do a keep, change, flip. Keep the top one. Change it to multiplication. Flip that bottom one. And then just simplify as much as possible. One of my cosines cancels. Multiply across. I'm going to get a cosine of x. Sine times sine is sine squared of x, and that is exactly what I was trying to prove. All right, so the advantage here for something like this is I have everything in cosine. So at this point, if I have everything in one trig function, I am going to move everything to one side of the equation. All right? If things cancel and I don't have a square, then I won't have to do factoring. I can just move my numbers over. If everything does not cancel, I'm going to have to factor. All right? And so for this one, I would move this 5 cosine squared over. I would move this 3 cosine over. That's a minus. And then I would move that 1 over. All right? Now, here's where you struggled on your current quiz, all right? Some of y'all got to this point and you took like a cosine out. You can't take a cosine out. There's a 1 that doesn't have a cosine to give you. You need to look at this guy as what it is. It's a polynomial, okay? And so if you have to, over to the side, go, okay, instead of cosine, I'm going to write 2x squared minus 3x plus 1. How would I factor that? Okay? How would I factor that? Well, you would have to do x plus something and x minus something, right? And so when you're thinking about this particular guy, I would say, well, x minus 1 right there, right? So I would have 2x squared, negative 2x, negative 1x, that's negative 3x, 1 and 1. There we go. That's my factoring. But instead of x, I have cosine of theta, okay? And so now I can go back over here and say, oh, okay, so I have 2 cosine of theta minus 1, cosine of theta minus 1 equals 0. And now I can set each one of these equal to 0, right? And I can say, well, cosine is going to equal 1/2, or cosine is going to equal 1. There are 2 places that I have a cosine of 1/2. There's 1 place that I have a cosine of 1. I need to give those from the unit circle, okay? So if you cannot look at the trig and function and factor it, write it out with an x and do your factoring like you would with just an x there. Once you've identified this, you're just going to go to your unit circle and say, what angle gives me a cosine of 1/2? And so positive 1/2 happens in the first quadrant and in the fourth quadrant for cosine. And then what angle gives me a positive 1? Well, that is 0. And so these would be your 3 answers for theta. If it is in radians, you are welcome to rewrite it in degrees. Some of you did that because degrees just work better in your brain. This is an easy one, so it's like 3 pi over 12, 4 pi over 12, which reduces. So a lot of you got to this point with no problem. You even reduced it with no problem, right? But then this is where we had some issues. To plug it into your equation, remember for sum and difference, right? It's cosine of the first, cosine of the second. It's opposite. So since I used a plus, it's going to be minus sine of the first, sine of the second. You need to actually give me those on the unit circle. If it's positive and negative, it needs to be plugged in there correctly, okay? Make sure you know your cosines and your sines for those angles. If you don't, use your blank unit circle and figure it out, okay? The biggest problem here was your positives and negatives. Honestly, the most that I counted off for this was in positives and negatives, really. And then you actually have to go plug it in. What is the cosine of pi over 4? It's square root of 2 over 2. What is the cosine of pi over 3? Square root of 3 over 2, okay? What is the sine of pi over 4? What is the sine of pi over 3? Actually, I flipped those, right? Cosine of pi over 3 is 1/2. So you have to make sure that you plug those in and then simplify. I will also say that for this particular one like this, some of you did your multiplication wrong. So when you have a square root times a square root, it is just multiply what's in the roots, and then you can't add roots if they're not the same. So like you cannot add square root of 2 and square root of 3. You can multiply them, but if they are added in the numerator, you leave them as square root of 2 plus square root of 3, or square root of 3 plus square root of 6, or whatever. You cannot add radicals if they're not the same. You can multiply them all day long. You may not add them. And so these will typically have a radical plus or minus a radical over a number. So to finish this one off, you're actually going to plug these in. To what they actually equal, and then simplify them. Multiply your numerators. Square root of 2 times 1 is square root of 2. Multiply your denominators over 4. And since you have a common denominator, you can just leave it with those radicals subtracted over 4. As I said, these will not combine, so those radicals stay the same. When it has given you something like number 33, it's really just wanting you to recognize that this is the tangent of the first angle minus the second angle. All of that simplifies to this. And so my first angle is negative 6x. My second angle is just 1x. And so that would simplify to just the tangent of negative 7x. Okay, so given something like this, you see that they've given you sine. They've told you that you are in your second quadrant. And they want the half angle identity here. So I have to go back to what is my half angle identity? Well, that is going to be the positive or negative of the square root of 1 minus the cosine of theta over 2. So I have to have my cosine, which again, you can use any of your methods to solve. I can say sine squared of x plus the cosine squared of x, or theta, equals 1. Remember, when you square this, you have to square the outside, so that's 4 times 10 over 49. To solve for the cosine squared, just subtract that over. So cosine squared is going to equal 1 minus 40 over 49, which is going to give me 9 over 49. I do have to take the square root, so that is 3 over 7. Because I am quadrant 2, that's negative 3 over 7. And now I can plug it in. So if I'm looking for my half angle, then I'm going to say the positive or negative root of 1 minus negative 3/7 over 2. Just simplify it. That's going to be 7/7, right? Common denominator, this becomes plus. So 10/7 over 2. So square root of 10 over 14. You can reduce it. You can reduce it before you rationalize it. So you can reduce it just like you would any fraction. You end up with the square root of 5 over 7, which is the square root of 5 over the square root of 7. You do want to multiply the top and the bottom by that square root of 7. So you have the square root of 35 over 7. We were in the second quadrant, so if I'm cutting the angle in half, I'm either going to be in the first or second quadrant, which means my sign is going to stay positive here. Once again, your half angle, there's only one option. It's not like you can pick 15 different things to plug in there, okay? This is going to be a square root. So when I plug this guy in right here, he's going to be a square root. So I won't do it. I won't do it fast. Well, we won't do it without skipping some steps. There we go. 4. So what do I put in here? What is that guy? 1 plus the cosine of over 2. Okay. If I just gave you a radical equation, what's the first step in a radical equation? Get the radical by itself. Okay, that is your first rule in solving for a radical, which means, so in this case, I would actually probably move the whole radical over, right? So I have 4 times this guy equals 3 plus 2 cosine of theta. My next step is to square both sides to get rid of that radical. So again, when I'm squaring something outside of the radical, I have to actually square it. This becomes 16, all right? The radical goes away, so I have this guy right here, all right? When I square this, I have to FOIL. It is 3 plus 2 cosine, 3 plus 2 cosine. Right? So I end up with 9 plus what? 12 cosine of theta plus 4 cosine squared of theta, right? So I have to do that. I can't just like square one and square the other, okay? Simplify, I mean, this becomes an 8, distribute 8 plus 8 cosine of theta. Then just move these guys over, subtract the 8, that's a 1. I'm going to put it back in order. So I'm going to say 4 cosine squared of theta. I'm subtracting 8 plus 4 cosine of theta, and then plus 1, right? Something like that, all right? Then you need to factor it. And again, if you have to say 4x squared plus 4x plus 1 and factor it that way, it's a perfect square trinomial, by the way. So it's 2 cosine plus 1, 2 cosine plus 1, all right? Which means cosine equals negative 1/2. That happens twice on the unit circle. Go back and tell me where it happens, okay? So your biggest issues here are manipulating the equations. And if you have to put an x in for your trig function until the very end, you can do that. You can literally put in an X for all of these while you're manipulating it. And at the end, go back and say, okay, X was actually cosine. And so now I'm going to plug a cosine back in to figure out what my unit circle is going to give me, okay? So if the factoring is throwing you off because there's a trig function in there, fill it in with a variable until the very end and put your trig function back in, okay? All right, so at this point right here, you're going to factor it. So we get 2 cosine of theta plus 1, 2 cosine of theta plus 1. That's my factoring, right? And then I'm going to set that factoring equal to 0. 2 cosine of theta plus 1 equals 0. Subtract and divide. Cosine of theta equals -1/2. Where on the unit circle do you have a cosine of -1/2 is what you're telling me at this point. All right, so it's going to be in the third and fourth quadrant. Your 60-degree angles in the third and fourth quadrant. Okay? So like 7 pi, 5 pi over 3 and 7 pi over 3, right? Right? So then you would give me those answers. Okay, when it says solve the triangle, you need to give me the measure of every angle and every side. So I'm going to immediately write angle A, angle B, angle C. Fill in what I know. I really only know angle B here. Side length A, side length B, side length C. And then fill in what I know. I know side length B, and I know side length A. So if I have an angle on the side opposite, I'm going to use law of sines. And so I'm going to say, well, the sine of 94 degrees over 32 equals the sine of A over 17. And then I'm just going to solve, multiply both sides by 17. That is the sine of A. So that means to solve for A, I'm going to have to use inverse sine. And solve for that angle. So when you do that, you get 32 degrees, which means that is my angle measure here. You can just do your 180 minus those two to figure out C. So C is going to be 180 minus the 32 minus the 94, which is going to give you 54 degrees. And then I can use law of sines to solve for my side length of C. So I can go back to law of sines and solve for him. Now for something like 57, since you don't have any angle measures, you're going to have to use the law of cosines. So once again, I'm going to write this down. And then I am going to use law of cosines to solve for one of my angles. And so just like I mentioned, when you do this, you do want to use your shortest side really when you're solving back for an angle, because it is going to give you a reference angle. So for example, in this one, B is 94. It corresponds to my longest side. So if I had been solving for angles here, I would have started with one of the smaller sides because I know they're not going to give me an obtuse angle. And so when I'm solving for this one, I'm probably going to use the B so I can solve for angle B. And so I'm going to set that up and say, well, 8 squared is going to equal my other two sides squared minus the 2 times those sides cosine of that B, which means I need to back all that over. So I need to say 8 squared minus 15.9 squared minus 9.6 squared divided by that -2 times 15.9 times 9.6. That will equal the cosine of B. I can put all of that into my calculator under my inverse sine. So I can do inverse sine of all of that. Just make sure you do parentheses around this, divided by, and parentheses around this when you put it into your calculator. When you do that, you should get 23 degrees for B. And now I can use my law of sines. Because I have one of my angle measures, I can say, well, the sine of 23, which is b over 8, equals, and again, I'm going to go to my shorter side here, the sine of c over 9.6. And again, c is going to equal that inverse sine of the sine 23 times 9.6 over 8. That rounds to about 28 degrees for C. And then you can use your 180 minus 23 minus 28 to get that A is going to be 129 degrees. And you have solved the triangle. All right, so your formulas for area. You're either going to use just your area formula, which is the 1/2 side A, side B, sine of C, which means you have to have the angle and the sides that make up the angle, like this example right here. So for this, I could go straight to that formula. 1/2, the one side times the second side, the sine of the angle in between them. You will get your area of 18.8 square centimeters for that one. For something like this, you can use this, but remember, you need the sides on either side of this. So you really need side B here, or you need angle B. And so I can solve for angle B by using law of sines. I can say sine of A over 15 equals sine of C over 15. These happen to be an isosceles triangle, so you can use law of sines here. When you do that, you're going to get that this is also 17 degrees. And then you can use 180 to calculate this guy. And you can once again do 1/2 ABC. But you have to have the angle and the sides that actually make that angle to use it. And you may have to use law of sines or something like that to be able to do it. Now, if you are given something like 62, where all you have are the three sides, you're going to have to use Heron's formula. And so for Heron's formula, you need your semi-perimeter multiplied by what happens when you subtract each of those and take the square root. All right, now remember, semi-perimeter is just like what it sounds. You take the perimeter and you cut it in half. So if I'm going to find my semi-perimeter here, I'm going to say half of my actual perimeter. So half of 14 plus 15 plus 9. So my semi-perimeter here is 19, and then I just plug it in. My area is going to be 19 times 19 minus my first side, 19 minus my second side, 19 minus my third side. And you're just going to plug that in and round it. And so you should get an area of approximately 61.6 square feet. Okay, I've picked 2 word problems to solve here, just so you can see how we're setting up. So we have Jason and Renee. They are on a seashore, and they are 10 miles apart. And so they've given us this measurement here. They can see the same ship in the water. The angle from Jason's point of view is 35, and the angle from Renee's point of view is 45. And so looking at the same ship then is going to give us a triangle kind of like this. His point of view is 35. Renee's point of view is 45. They want to know how far the ship is from Jason. And so that's this guy right here, if this is my ship. And so we really have a law of sines here. You can calculate what this angle is using 180. So if I say 180 minus 35 minus 45, this angle here is 100 degrees. So I can do, 100 over, or rather, actually, we're going to do it the other way. We're going to say 10 over the sine of 100 equals x, which is how far it away is from Jason, over the sine of 45 degrees. And then I just calculate it. So x is going to equal 10 times the sine of 45 divided by the sine of 100. And so I will get that Jason is approximately 7.2 miles away from the ship. Now, if I look at this third one, I have Andrew, Isaac, and Noah are camping in their tents, and then they give me just distances. So I'm still going to have this triangle here. The distance between Andrew and Isaac is 153 feet. Between Andrew and Noah is 200 feet. Between Andrew and Noah is 201 feet. And between these two is 15 feet.